If you are aiming for a 6 or a 7 in IB Math AA, this mock paper is exactly what you need. Welcome back to IB Mathology, your space for mastering IBDP mathematics. Today we are going to solve a carefully designed AA mock paper that combines multiple topics just like the real IB exam. So let's start with solving some mock questions. In this question, it says let A and B be the events such that A intersection B is 1 by 5. Probability of event B given that A has already occurred is half, and probability of A given that B has already occurred is 3 by 10. We have to find PA union B. So to solve this question, we have to first use the formula, that is PA slash B, which is nothing but PA intersection B divided by the probability of the B event which has already been occurred. Now A by B is given to you as 3 by 10 and A intersection B is given to you as 1 by 5. So from here we can find probability of event B as 2 by 3. Similarly, we can find probability of B where A has already been occurred. It's the same, just the denominator will have probability of event A. So from here, it is given to us as half and A intersection B is again 1 by 5. So we can find probability of event A, which is nothing but 2 by 5. Now I will be using PB and PA to find A union B. We will apply De Moivre's theorem. PA union B is nothing but probability of A plus probability of B minus the intersection or the common portion between A and B. PA is 2 by 5. PB we calculated as 2 by 3 and PA intersection B is given to me as 1 by 5. Now after taking LCM, we will be getting 13 upon 15 as our answer. So PA union B will be 13 by 15. Now let's move to the next question. Now in this question, we have to use proof by contradiction to prove that there are no positive integers A and B such that A square minus B square is equals to 2. So let's start with the solution. So for this, we will first assume that A square minus B square is equals to 2. Then A cannot be equals to B. Now we can apply the identity and I can write it as A minus B into A plus B, that is equals to 2. So from here I can write A minus B as 2 upon A plus B. Now since A and B belongs to positive integers and A is not equals to B, it means my A minus B value will always be between 0 and 1. Now I will be substituting A minus B value from here. So I can write that 2 upon A plus B will be in between 0 and 1. It means it follows that A minus B is between 0 and 1. And this is a contradiction. Why? Because it is given to us that A and B are positive integers. Then I can write that A minus B will also be an integer. However, if A minus B is in between 0 and 1, it means A minus B cannot be an integer because it is falling between 0 and 1. Therefore, there are no positive integers A and B such that A square minus B square is equals to 2. So like this we can explain this. Now let's move to the third question. Now in this question, g dash x is given to us like this, and there is one condition which is g of 1 is equals to 2 is also given. We have to find gx. Now to find gx, since g dash x is given, so first I will write g dash x as ln x whole square by x. Now to get gx, we have to integrate both sides with respect to dx. So g dash x integration will become gx, and in this we cannot directly integrate the right hand side. So what we will do is we will assume ln x as u. We will be using substitution method. So if I differentiate both sides, I will get 1 upon x as du over dx. So from here I can find out dx value, which is nothing but x du. Now I will be substituting u value and du value. So I have to write it as du basically. So du will be dx upon x. So I will be substituting du value and u value. I will name it as equation 1. So if I substitute, I will get gx as integration ln x was u, so it becomes u square, x remain as it is, and my dx will be x du. So it's your wish whether you want to substitute this or this. It's better if we substitute dx here. X will get cancelled out and integration will be u cube by 3, but there will be a c added because it's a definite integral. Now we have to substitute u as again ln x because my question was in x. Don't forget to replace whatever you have substituted as the original function. So I got my gx as ln x whole cube by 3 plus c. Now I will be using this condition, which is g1 is equals to 2 in my answer. It means if I substitute x as 1, I will get answer as 2. So I can write as for x is equals to 1, my gx will be 2. So if I replace, I will get 2 is equals to ln 1 whole cube by 3 plus c. And ln 1 is 0, so I got my c value as 2. Hence, I can write gx as ln x whole cube by 3 plus 2 as my final answer. Now let's move to the next question. Now in this question, we are given with the graph of y is equals to fx between minus 2 and 2. The graph has a horizontal tangent at minus 1, 3 and 1, 1. It means it has a horizontal tangent and this point. On the set of the x's is given to you in the answer, sketch the graph of f of 2x minus 4, where we have to indicate the coordinates of any local maxima or minima. So before drawing the graph, let me first write my y as, which is given to me as 2x minus 4. I can write it as, I can take 2 common and I can write it like this. It means this is formed by a sequence of 2 transformation in fx. It means my original function fx has a horizontal shrink. So I can write that horizontal shrink by a scale factor of half because there is a 2 here, followed by the horizontal translation of 2 units to the right. Horizontal translation of 2 units to the right because it is x minus 2. So when we will put x minus 2 is equals to 0, we will get x as 2. So when we'll do these 2 transformations, the first one is this one, shrinking by a scale factor of half, and then translation to the right, we will get this curve. As I have I have first shrink the curve, the function, and then I have moved everything towards the right. It means we have nothing in the left side of the curve. Now let's move to the next question. Now in this question we are given with a function 2x plus 3 upon x minus 4. In a part we have to find its inverse. So to find the inverse, first I have to write it as equals to y, and then I have to find out the inverse. So what I can do is I can do cross multiplication. So 2x plus 3 is y into x minus 4. So 2x plus 3 is equals to xy minus 4y. Now I will be making a shift, and I will be keeping the like terms to one side. So I can write it as minus 4y minus 3. I can take x common. So this become 4y minus 3. So my x will be, if I take minus common, 4y plus 3 upon 2 minus y, and if I translate this into the denominator, so my x will be 4y plus 3 upon y minus 2. So what I have done is, my original question was in terms of x. Here I had y as the subject, and here I made x as the subject. So this is nothing but h inverse x. Now for the B part of the question, it says there is a function k such that h inverse O of k inverse, means it is a composite function given to me, and I have to show that my kx is x minus 1 upon 4. So let's first start with writing the composite function. So my composite function means instead of x, I am putting right now kx to get to the answer. You can write kx in the bracket also. That is the correct way to write. Now to write, I can assume it as y. So if I assume it as y, I can write as 4y plus 3 upon y minus 2, which is given to me as 4x plus 8 upon x minus 9. Now most of the work has already been done, so I just have to simplify this. So I am cross multiplying. So I will get this as the expression, and now I just need to open the brackets. So I will write it like this: plus 3x minus 27, that is equals to 4xy minus 8x plus 8y minus 16. Now on solving this, I will get my final answer as 44y. I can take 11 common, so I can write it as 4y. It means my y value is nothing but x minus 1 by 4, and y was, I have taken y as kx, so I got my kx as x minus 1 upon 4. Now let's move to the next question. Now in this question we have to solve for x. So let's start with the A part. I will first write the question: minus ln x plus 4. I will be using ln a plus ln b in these two, which is ln a into b. So I can write it like this. And now I can use ln a minus ln b property in this, or I can first I will write this, and I can write it like this also. Since both sides we have ln, so we can compare the brackets. So I can write it like this, and now after opening the bracket I will get this as the expression, and on simplification I will get x square minus 3x minus 4 as my equation. Now we can use middle term splitting. So after middle term splitting, I will get x minus 4 or x plus 1 is equals to 0. This means either x minus 4 is 0 or x plus 1 is 0. This give me x value as 4, and this will give me x value as minus 1. Now we cannot take x is equals to minus 1 because we have ln x in the question, and If I put x as minus 1, ln minus 1, we cannot have negative numbers inside ln. So this will result in an error. Therefore, my answer will be x is equals to 4 for this particular equation. Now, in the B part, we have log with base 3 here, log with base 3 here. So we have to convert first this 1 into log with base 3. So I can write it as 4x square minus 5x minus 6 with base 3. 1 I can write as log 3 with base 3, plus I can put this 2 in the power. So I will get this. Now again I can apply log a plus log b here. My left hand side will be the same and right hand side will be log with base 3, 3 multiplied by x square. Again I have logs on both sides, so I can compare. So on comparing the brackets, I will get 3x square as my expression, and on further simplification I will get this equation. Now again I will do middle term splitting. So I will get x minus 3 into x plus 1 is equals to 0. This again says either x minus 6 is 0 or x plus 1 is 0. This will give me x as 6 and this will give me x as minus 1. Again we have log x in the expression. So x is equals to minus 1. We will reject because this term results in an error. So x is equals to 6 is the solution for the B part. Now let's move to the next question. In this question we are given with a random variable x which has a probability density function given as this. In the A part we have to show that a is pi by 4. So how we can do is, first of all, x limit is given to me from 0 to 2. So the probability of the random variable x between 0 and 2 is nothing but the integral of the function from 0 to 2, and if I am integrating from 0 to 2, my answer should be 1 because probability of the entire event is always 1. Now I will be replacing this fx 0 to 2 a sine pi x by 2 dx as 1. Since a is a constant and integration of sin x is minus cos, and we have to do the differentiation of pi x by 2 as well, which will be this between 0 to 2. This will be equal to 1. Now on further simplification, I can write it as minus 2a upon pi, and I can put my limit. So this will be cos pi, if I put upper limit as 2, minus lower limit is 0, that is equals to 1. I can write it like this. Cos pi is minus 1, cos 0 is 1. So I can write it as 4a upon pi as 1, which will give a value as pi by 4. This is what we have to show. Now let's move to the B part. Now for the B part, we are given with the probability from 0 to q, and we have to find this q. So I will again be using the same thing. Integration 0 to q fx dx will be equals to 0.25. So it becomes 0 to q. Now I can use my a value as pi by 4. So I can write pi by 4 sine pi x by 2 dx, and this 0.5 I can write as 1 by 4. Now on integration, sin x integration is minus cos pi x by 2 whole divided by pi by 4 is here, whole divided by pi by 2, and now I have to put the limits from 0 to q, and it is equals to 1 by 4. So if I further simplify, I will get minus 1 by 2 cos minus q pi by 2 upper limit minus cos 0, which is my lower limit. This entire thing is equals to 1 by 4. So I can further simplify and write it as 1 minus cos pi q by 2, that will be equals to 1 by 2. And this cos pi q by 2 will be equals to 1 by 2 if I solve this 1 and 1 by 2. And we know that cos is half at pi by 3. So my left hand will be as it is. This I can write as cos pi by 3. It means pi q by 2 is equals to pi by 3, which will give me q value as 2 by 3. So this is my value of q. Now let's move to the next question. This question says the angle between unit vectors v and w is 60 degree. We have to evaluate modulus of 3v plus 4w. So for this, first of all, these are unit vector. It means modulus of v and modulus of w should be 1. And we know that cos 60 is half. So I can use dot product. So v dot w is modulus v modulus w cos 60. So if I put all the values, I will get mod v dot w as 1 by 2. Now I have to evaluate 3v plus 4w. So what I can do is I can do the square. So I can write it as 4w 3v plus 4w. Why I am doing is because modulus of any vector square is nothing but a dot a. So I am using this property. Now I can open this bracket. So this will give me 9v dot v plus 24v dot w plus 16w dot w. So v dot v is nothing but modulus v square. V dot w we get as 1 by 2 and 16w dot w will be the modulus w square. Since modulus v and modulus w is 1 because they are the unit vectors, so I can write my answer as 16, which is nothing but 37. And this entire expansion was equals to this, so I can write it like this. It means my modulus of 3v plus 4w is nothing but root 37. Let's move to the next question. In this question, we are given with a function and a portion of fx is shown. We have to express this in this form, and hence we have to find the value of a, b and c. So first we will write what is given to us as the function, and on the right hand side we will write c upon x plus 2. So my left hand side will be the same. I have to take LCM of x plus 2 on right hand side. So I can write ax plus 2 plus b into x plus 2 plus c. Now these two I can cancel. I have to open the right hand side. Ax square plus 2ax plus bx plus 2b plus c. Now I will simplify. I can take x common. This will give me 2a plus b and my constant is 2b plus c. Now I can compare and I can write a as 2 and x coefficient is 1. So 1 will be equals to 2a plus b, and constant, which is minus 3, this will be equals to 2b plus c. On comparing, so I can write a as 2. The next one is 2a plus b as 1 and 2b plus c as minus 3. So I got a as my answer. If I substitute a here, I will get b as minus 3, and if I substitute b value here, I will get c value as 3. So I got all three values. Now the b part says it has two asymptotes. One asymptote is the vertical line at x is equals to minus 2. We have to write the equation of the other asymptote. So to solve this, first I will write my function by putting all ABC values. I get this. So if I write, because we are talking about asymptotes, means x tends to infinity, so fx value will be 2x minus 3. It means it has an oblique asymptote which is nothing but y is equals to 2x minus 3. So this is my equation of the second asymptote. Now in the C part it says show that the area of the region bounded by the graph and the x-axis is this. Now to solve this, to get the x's, first I have to put fx is equals to 0. My fx was this. So if I put it equals to 0 and I use middle term splitting or factorization, I will get these two as the factors. It means either 2x plus 3 is 0 or x minus 1 is 0. So x is equals to minus 3 by 2 or x is equals to 1. So I got my 2x intercepts. Now I have to find area. Area means I have to integrate, put my lower limit and upper limit and my function, which is this. Now I have to use simple integration. So my area will be x integration is x square by 2. So this 2 will get cancelled, minus 3x plus 3. 1 upon x plus 2 integration is ln modulus x plus 2. Now once integration is done, I have to put the limits. So to put the limits, if I put upper limit, so I will get 1 minus 3 plus 3 ln 3. And if I put my lower limit, I will get 9 by 4 plus 9 by 2 plus 3 ln half. And if I further simplify this, I will get minus 35 by 4 plus 3 ln 3 minus 3 ln half, which on further simplification is 3 ln 6 minus 35 by 4. This is what was required by the question. Now we can move to the next question. In this question we are given with the complex number cos theta plus I sin theta, and we have to prove using induction that for a positive integer n, this. So let's start. Since we have to do mathematical induction, so we have to start for n is equals to 1. So if I put n as 1 in the given expression, it will be power 1, that is nothing but cos 1 into theta plus I sin 1 into theta, which is nothing but cos theta plus I sin theta. So we can say that it is true for n is equals to 1 as LHS is equals to RHS. Now for n is equals to k, we have to assume that it is true. So I can write cos plus I sin theta to the power k is equals to cos k theta plus I sin k theta. So this must be true for n is equals to k plus 1 also. So we can write this as cos theta plus I sin theta to the power k plus 1. This I can write as cos theta plus I sin theta to the power 1 multiply by cos theta plus I sin theta to the power k. Now using the assumption, I can use assumption in this. So this will remain as it is, and this will become cos k theta plus I sin k theta. Now I can open the bracket. I will open the bracket from here. Cos theta cos k theta plus I cos theta sin k theta plus sin theta sin k theta plus I square value is -1. So here I will write I square sin theta sin k theta. Now I can further write it as cos theta cos k theta plus I times, I can apply compound angle property and I can write this as sin theta plus k theta minus I square value is -1. So sin theta into sin k theta. So finally I can write it as cos theta cos k theta minus sin theta sin k theta plus I part, I can take theta common, so this will be 1 plus k into theta. And again I can apply compound angle identity in this. Cos A cos B minus sin A sin B, which is cos A plus B plus I sin 1 plus k theta. I can put it like this. So finally I can write my answer as cos 1 plus k theta plus I sin 1 plus k theta, which is nothing but the expansion of this expression. So this is true for n is equals to k plus 1. So it is only true for n is equals to k plus 1 if it is true for n is equals to k. So this is how we can prove this one. Now in the B part we have to use de Moivre's theorem to show this. So to solve this part, first of all z to the power n plus 1 upon z to the power n, I can write it like this, z to the power minus n. Now using de Moivre's theorem, what I can say is z to the power n plus z to the power minus n is nothing but cos n theta plus I sin n theta plus cos minus n theta plus I sin minus n theta, which I can write as this cos n theta plus I sin n theta. Cos theta is cos is an even function, so I can write as this, and sin is an odd function, so I can write it like this. These two will get cancelled out, so this is nothing but 2 cos n theta, and this is what we have to show. So my LHS is equals to RHS. Now in the C part, it says by expanding this to the power 4 we have to show this. So we have to use the result of B part to solve this. So z plus 1 upon z to the power 4, I can write it as 2 cos theta to the power 4 by using this result. Now since it is this, so I can write 2 to the power 4 is 16 cos to the power 4 theta. Now if I expand z plus 1 upon z to the power 4, you can use binomial expansion, or if you don't want to use that, you can write it like this and then further you can solve it. So on further expanding, this should be 2, and on further expansion it should be z to the power 4 plus 1 upon z to the power 4 times z square plus 1 upon z square plus a. I have not written all the steps, but if you will open these two squares and multiply them, you will get this only. So this I can write as 16 cos to the power 4 theta is nothing but 2 cos 4 theta plus 8 cos 2 theta plus 6, because I can write these two as these two terms. It means cos to the power 4 theta is 1 upon 8 cos to the power 4 theta 4 cos 2 theta plus 3. This is what we have to prove. Let's move to the next part. Now in this part, HC is given to me like this. I have to find, means I have to integrate. So I have to use the result of the previous part. So I can write cos to the power 4 theta as 1 upon 8 cos 4 theta plus cos 2 theta plus 3 d theta. And now I can simply integrate it. So if I integrate, I can take this common. Cos integration is sine plus 4 sine 2 theta by 2 plus 3 theta, and my limits are 0 to c. So HC I can take 4 common, so I can write it as, I am putting the upper limit sine 4c plus 8 sine 2c plus 12c. When you will put upper limit and lower limit, you will get this as the answer. So this is my first part answer. Now for the second part, it says it should be 3 by 8 of c. So to solve this, what I can do is, from this expression only, first I will write HC, which is 1 upon 32 sine 4c plus 8 sine 2c plus 12c. So I have to prove it as 3 by 8c. Since I do not have to prove, I have to solve this. So to solve this, what I can do is, from here I can write it as sine 4c plus 8 sine 2c should be equals to 0. So 8 sine 2c should be 8 if I apply double angle identity. So I can write it as sine c cos c, since sine 2 theta is 2 sine theta cos theta. Similarly, sine 4c I can write as 2 sine 2c cos 2c, using the same identity in these two. So this again I can write as 2 sine c cos c, and I have to convert cos 2c also into sine, so I can write as 1 minus 2 sine square c, which on expansion will be 4 sine c cos c minus 8 sine cube c cos c. So from here I can write as 4 sine c cos c minus 8 sine cube c cos c, and I had one extra 16 sine c cos c. This entire should be equals to 0. From the entire expression I can take 4 cos c common, so I will be left with 5 sine c minus 2 sine cube c, that is equals to 0. It means either cos c is 0 or 5 sine c minus 2 sine cube c is equals to 0. So from here I can take sine c common, so 5 minus 2 sine square c is 0. So if cos c is 0, it means c is pi by 2, and from here I can write as either sine c is 0 or sine square c should be 5 by 2, which is greater than 1, so we have to reject this, and from sine c is equals to 0 I can write that c is equals to 0. And since it is given to us that c lies from 0 to pi and c cannot be 0, so I can write as c is pi by 2. Now let's move to the question number 11. In this question we have plane pi 1 which has this equation and plane pi 2 has this equation. For what points which lie in both pi 1 and pi 2, we have to show that lambda is equals to mu. So to solve this question, we will assume that let pi 1 is equals to pi 2. So I can write R values. So 2 plus lambda times minus 218 plus mu times this should be equals to 201 plus s times 121 plus t times 111. Then after equating, I can say 2 minus 2 lambda plus mu is equals to 2 plus s plus t. 1 plus lambda minus 3 mu is equals to 2s plus t. And 1 plus 8 lambda minus 9 mu is equals to 1 plus s plus t. Now we have these three equations. So if I subtract, let me write this as equation 1, 2 and 3. Now if I subtract 1 from 3, what I'll get is s plus t plus 2 lambda minus mu minus s plus t minus 8 lambda plus 9 mu is equals to 0. So from here I can write this 10 lambda minus 10 mu is equals to 0, which will give me lambda is equals to mu. So this is how I'll solve first part. Now for the second part, it says find a vector equation of the line of intersection of these 2 points. So I can write my equation as R will be 2, 1, 1, which is for plane 1, plus lambda times minus 2, 1 and 8. Now instead of mu, I can again write lambda and rest of the things will be same. So R will be 2, 1, 1 plus lambda times minus 1, minus 2, minus 1. So this is my vector equation where these two planes intersect. Now in the B part, the plane pi 3 contains this line and is perpendicular to this. We have to find the Cartesian equation of plane pi 3. So on rearranging this equation, I can write as x minus 2 by minus 3, y minus 0 by minus 4, z plus 1 upon 1. So this is Cartesian form of a line. So Cartesian form of a line. So I can take my P point as 2, 0, minus 1, which lies on the line, and the normal vector I will take as n, which is 3i minus 2j plus k. So the equation of the plane will be 3 times x minus 2 minus 2 times y plus 1 times z plus 1 is equals to 0. So on simplification, I will get plus z is equals to 5. So this is my Cartesian equation of plane pi 3. Now in the C part, it says find the intersection of all these three planes. So from the A part, I can write as R as 1 minus this and 1 minus lambda. So this I can write as 2 minus lambda is x. I can write y as 1 minus 2 lambda and z as 1 minus lambda. And in the last part, I calculated my equation for plane pi 3 as this. So I can substitute because pi 1, pi 2 and pi 3 intersect. So I can substitute these points into this equation. So I will get 2 minus lambda minus 2 times 1 minus 2 lambda plus 1 minus lambda times equals to 5. So on solving this, you will see 5 LHS equals to RHS. It means it is true for all real values of lambda. So they all intersect at a line which is given to me as 211 plus lambda times minus 1 minus 2 and minus 1. So this is how I'll solve this. Now let's move to the next question. Now in this question we have to consider the differential equation this, where x is greater than minus 1 and y is 1 when x is 0. We have to use Euler method with a step size which is h is equals to 0.5, and we have to approximate the value of y when x is equals to 1. So you will use your formula booklet to write this value, which is h function of x and y n. So this I can write as, so what is the condition given to me? Y naught is 1 when x naught is 0 and h is given to me as 0.5. So the function of xn comma yn is nothing but dy by dx, which is y square upon 1 plus x. Therefore, I can find I can first find y1 as 1 plus 0.5. My y value is 1, so 1 square upon 1 plus 0. So this will give me answer as 1.5. My y2 will be y1, the previous value, plus 0.5 times. Now this is 1.5 and this will be 1 plus 0.5, which will give me an answer as 2.25. Therefore, when x is equals to 1, my y value is approximately equals to 2.25. And if you want to know how to solve this question using your calculator, so you can see my previous video where I have solved another mock paper and I have shown and written every step of how to calculate it using GDC. Now in this part I have to show the double derivative. So to solve this part, first of all, d2y by dx square is nothing but the derivative of the first part. Sorry, this should be x dy by dx. It means I have to take the derivative of y square divided by 1 plus x. So I can apply quotient rule, and on applying quotient rule I will write this as derivative of y square by denominator as it is, numerator derivative, minus numerator as it is, derivative of the denominator whole divided by denominator whole square, which is 1 plus x. So y square derivative will be 2y dy by dx minus y square as it is, and it will become 1 divided by 1 plus x whole square. So in this y I can write this dy by dx as what is given to me. So 1 plus x into 2y into y square upon 1 plus x minus y square whole divided by 1 plus x whole square. These two will get cancelled. So this is 2y cube minus y square upon 1 plus x whole square. So this is my double derivative of the function. Now in the next part, find Maclaurin series of y up to and including the term x square. So for solving Maclaurin series, this is the formula for Maclaurin series: f0 plus x times f dash 0 plus x square by 2 factorial f double dash 0 and so on. So f0 I can write as 1 because it was given to me also in the question. F dash 0 will be 1 square upon 1 plus 0, which is 1, and the double derivative which I just calculated here in the first part, so I can write as 2 plus 2 bracket 1 cube 1 square upon 1 plus 0 whole square, which is 1. So Maclaurin series expansion will be 1 plus x square by 2, because we have to do it till x square only. Now in this part we have to solve the differential equation. So the differential equation given to me was dy by dx is equals to y upon 1 plus x. I have to separate the variables, so I can write 1 upon y dy as 1 upon 1 plus x dx. My apologies, it was y square, not y. Once I have separated the like terms, so now I can integrate both sides. So left side integration will be minus 1 upon y and right side will be ln 1 upon x plus c. So from here I can write, because I have to solve, so my solution will be in y. So it should be ln 1 plus x plus c. This is how we will solve. Now I have to find the c value. So for c value, I have to use y0, which is minus 1 upon ln 1 plus 0 plus c, which was given to me as 1. In the earlier part, if you see, y0 is equals to 1 was given. So c is coming as minus 1. Thus, I can write my solution as minus 1 upon ln 1 plus x minus 1 is my complete solution to the differential equation. Now in the second part, we are given that limit x tends to ay is plus minus of infinity. We have to find a. So I can write that x tends to a minus 1 upon ln 1 plus x minus 1. This should be plus or minus infinity. It means my ln 1 plus a, I can replace this x by the limit minus 1 should be 0. So I can write it as ln 1 plus a is equals to 1. I can convert base to log to exponent. I will get this. So a value is e minus 1. So this is how I will solve the second part. So that's the full mock paper breakdown. If you want more full mock paper solution like this, let me know in the comment box. Don't forget to subscribe IB Methodology. We are building consistent 7-level preparations here. See you in the next video.